Hello everyone, hope you are doing well. I am Akshay Parmar, Assistant Professor at LJIET Institute of Engineering and Technology in IT/IC department. Today we will discuss an important data structure topic, that is digital to analog conversions, right? Let's move forward about the outline of this today's video. Here we will discuss the digital to analog conversions, right? After that we will discuss its type. Before diving into the digital to analog conversion, let's see what is digital signal and what is analog signal, right? So what is digital signal according to you and what it represents, right? So a digital signal is a signal that represents the data as a sequence of discrete values. At any given time it can only take a one of the finite number of the values, right? What is analog signal then? An analog signal is any continuous signal for which the time varying feature of the signal is representation of some other time varying quantity. For an example, analogous and another time varying signals, right? So let's see why we are using the digital to the analog conversion. So it is the process of changing one of the characteristics of the analog signal that is based on the information in the digital data, right? So this is the sender which is sending the digital data, the bit sequence, right? So it will give this that digital data to the modulator. After that, that modulator will convert that digital data into the analog signal, right? So here we are going to learn about digital to analog conversions. After making the analog signal, that analog signal is transferred in the by using the link and send it to the demodulator, which is at the receiver side, right? So the analog signal is transmitted by the transmission media using that link and reach at the demodulator. That demodulator will convert that analog signal into the digital data, and the receiver will get our actual digital data, right? So that's how this process is working. To convert the digital data into the analog signal, there are so many various techniques, right? So in the digital to analog conversions, there are mainly three methods. So there are mainly three methods, right? ASK, FSK and PSK. ASK stands for the amplitude shift keying, FSK stands for the frequency shift keying, and PSK stands for the phase shift keying, right? So let's see one by one in detail. So what is ASK? The amplitude shift keying. And in the amplitude shift keying is a technique in which carrier signal is analog and the data to be modulated in the digital, right? The amplitude of the analog carrier signal is modified to reflect the binary data, right? We can say that the digital data is in form of the binary data. So the amplitude of the analog carrier is modified some way to reflect that digital data, right? Binary signal when modulated gives a 0, the value when the binary data represents the 0. When it gives a carrier output when data is 1, right? The frequency and the phase of the carrier signal remain the constant here. Let's see by one example, right? So here we have taken an 1 bit sequence 1011001001, right? So this is the carrier signal that we are going to represent, right? After changing its amplitude, we are getting the digital data into the analog form, right? If we are representing that bit 1, that carrier remain that same, right? So to represent that bit 1, that carrier will remain at same, right? So we are getting that same analog signal like that is, right? After that the bit 0 is there. To represent the bit 0, we are changing the amplitude at the 0 level, right? So that 0 is there, right? After that 1 bit is there. So to represent that bit 1, that carrier signals are remain as it is, right? So we are representing that carrier signal. After that 1 bit is there. So the same way, the same procedure we are following. To represent the bit 1, the signal carriers is remain as it is, and whenever the 0 is occur, so the amplitude of that signal is going to the 0, right? So to represent that bit 0, we are changing its amplitude to the 0, right? Another 0 is there. So same way, the to represent the bit 0, the amplitude of the signal is changed to the 0, right? After that the 1 is there. So as we have shown that the carrier signal remain as it is to represent the bit 1. Likewise, we are representing that bit sequence into the analog signal, right? That's how we are converting that digital data into the analog form, right? So right, so this is how we are doing an amplitude shift keying, ASK method, right? So there are some of the advantages and the disadvantages also, right? So advantages of using the shift keying, amplitude shift keying, is it can be used to transmit digital data over a optical fiber, right? As you all know, this is the new generation of the data communication. So the amplitude shift keying is used to transmit the digital data over the optical fiber also. The receiver and the transmitter have a simple design, which also make it comparatively inexpensive, right? So the devices which are used for the ASK is a little cheaper. It uses the lesser bandwidth as compared to FSK, that is a frequency shift keying. Thus it is offer the high bandwidth efficiency, right? So that are the advantages of the amplitude shift keying, ASK. Some of the disadvantages are also there. It is susceptible to the noise interface and entire transmission could be the loss due to this, right? While we are using the ASK, there are interface and the noise is there, right? So the entire transmission could be lost due to that noise, and it has the lower power efficiency, right? So this is the disadvantages of the amplitude shift keying, right? This is all about the amplitude shift keying. After that, let's see it's another type, the frequency shift keying, right? So let's see a frequency shift keying. In that, what we are doing in this modulation, the frequency of the analog carrier signal is modified to reflect the binary data, right? As in the ASK we are modifying the amplitude, in the frequency shift keying we are modifying the frequency of that analog carrier, right? So the output of the frequency shift keying is modulated wave is high in the frequency for the binary high input and the low in the frequency for the binary low output, right? The amplitude and the phase of the carrier signal is remain the constant, right? So likewise, whenever we are representing the higher bit, right? So that is suppose an bit 1. So we are representing it by we are representing that by a signal of which is having the higher frequency. Whenever we are representing bit 0, we will represent that bit by the signal which have the lower frequency. Let's see it by the one very good example, right? So as that bit sequence 1011001001 is there, right? So for measuring that frequency shift key, the analog signal is there, right? So whenever the bit 1 is there, so we will represent that bit 1 by the signal which have the higher frequency, right? After that, whenever we are moving forward about the bit 0, it will be represented by the signal carrier signal which have the lower frequency, right? So as you can see that whenever we are representing bit 1, the carrier signal have the higher frequency, and whenever we are representing bit 0 which have the lower frequency, right? So that's how we are representing the bit 1 and the bit 0, right? So we will follow this method, or whenever the bit 1 is encountered, we will use the signal which have the higher frequency, and whenever the bit 0 is there, then whenever the bit 0 is encountered, we will represent that bit by the signal which have the lower frequency, right? So after that, the bit 1 is there, so we will represent that bit by the signal which have the higher frequency, right? So like that, bit 1 is there, so we will represent that bit by the signal which have the higher frequency. After that, the bit 0 is there, after that the bit 0 is encountered, so it will be represented by the signal which have the lower frequency, right? So we will represent that bit 0 by the signal which have the lower frequency. After that, the bit 0 is there, so we will continue that signal with the lower frequency, right? So that's how we are representing the bit 0. So to represent that digital data, we are modifying the signal, analog signal. We are here in the FSK, we are modifying its frequency, right? So to represent the higher bit, we will represent it by the signal which have the higher frequency, and to represent the signal which have the lower value, we will represent by the lower frequency, right? So that's how we are representing that bit sequence by the analog signal, right? So that's how we are converting that digital data into the analog data. This is about the frequency shift keying. That's how the frequency shift keying is working, right? So in the ASK, we are modified the amplitude of the signal, and in the frequency shift keying, we have modified the frequency of the analog signal, right? So the advantages and the disadvantages of the FSK. The frequency shift keying modulated signal can help to avoid the noise problem that is there in the ASK, right? So whenever we are using the ASK, the noise problem is there, right? So the entire signal may be lost. So to overcome that problem, the FSK is there. So frequency shift keying modulated signal can help to avoid the noise problems. It has the lower chance of an error, right? So it provides a higher signal to noise ratio. The transmission and the receiver implementation are simple for the low data rate application, right? So this is advantages about the FSK, frequency shift keying. After that, let's see the disadvantages about the FSK. It uses the larger bandwidth as compared to ASK, right? Thus it offer the less bandwidth efficiency. It has the lower power efficiency. This is the major disadvantages of the FSK, right? This is all about the frequency shift keying. After that, let's see the phase shift keying, right? So the third part of the digital to analog conversion. So what do you mean by the phase shift keying, PSK? In this type of modulation, the phase of the analog carrier signal is modified to reflect the binary data. The amplitude and the frequency of the carrier signal remain the same. Whenever we are doing the phase shifting, we will only modify the phase of that analog signal. We will not touch any other characteristics such as the amplitude and the frequency. It will be remain same as it is, right? So the phase shift keying has the further two subtypes, the binary phase shift keying and the quadrature phase shift keying, right? So let's see how the phase shift keying is working. So right, so as we have taken the example of that bit sequence 10 or 11 how that digital data is converted with the help of the phase shifting by just simply changing the phase of that analog signal, right? So first of all, basically we are representing bit 1 by this phase, right? So whenever the bit 1 is happening, it will be kind of following this. After that, whenever the bit 0 is occurring, that its phase is reverting to the 180 degree, right? So that it will be inverted its phase, and that's how we are representing the bit 0, right? So whenever we are representing that bit 1, we will follow the signal which have the phase that kind of, right? And whenever we are representing the bit 0, we will invert that phase to the 180 degree, and we will represent that second bit, right? So that is 0. So that's how we are representing bit 1. So whenever the bit 1 is occurred, that phase shift has the this kind of, right? So after that, whenever the bit 0 is encountered, its phase is reversed, or it will be modified, it will be shifted to the 180 degree, right? Or it will be shifted to the 90 degree, right? So that's how we are representing that bit 1. After that, bit 1 is there, so there are no need of the phase shifting, right? So there are no need of phase shifting, so it will be remain as it is. After that, the bit 0 is there, so it will be required to the phase shifting, so it will be shift that its phase and represent the bit 0, right? So likewise, we are representing that digital data into the analog signal by simply changing its phase of that signal, right? So after that, this is how the digital data is converted into the analog signal, right? So this is about the phase shift keying, the how the phase shift keying is working. After that, let's see about its advantages and the disadvantages. The advantages is it is the more power efficient modulation technique as compared to the ASK and the FSK. It has the lower chance of the error, right? So it allows the data to carry along the communication signal much more efficiently as compared to the FSK. The disadvantage of the phase shift keying is it offers a low bandwidth efficiency. the detection and the recovery algorithm of the binary data is very complex for the phase shift keying. So this is the advantages and the disadvantages about the phase shift keying. After that, let's see its two subtypes: binary phase shift keying and quadratic phase shift keying. In the binary phase shift keying, BPSK is also known as the phase reversal keying, or the 2PSK is the simplest form of the phase shift keying, right? The phase of the carrier wave is changed according to the two binary input. In the binary phase shifting, the difference of 180 phase shift is used between the binary 1 and the binary 0, as we have shown in our example, right? So whenever we are representing the bit 1, after that, whenever the bit 0 is encountered, we will we will shift that phase to the 180 degree, right? So this is regarded as the most robust digital modulation technique, and it is used for the long distance of the wireless communication. After that, let's see the quadratic phase shift keying. So what is the quadratic phase shift keying? This technique is used to increase the bit rate. For an example, we can code 2 bit into the one single element. It uses 4 phases to encode the 2 bits per symbol. Quadratic phase shift keying, QPSK, uses the phase shift of the multiplies of the 90 degrees. It has the double data rate carrying the capacity compared to the BPSK. The BPSK, as 2 bits are mapped on the each constellation. It has a double data rate carrying the capacity compared to the BPSK, as 2 bits are mapped on the each constellation points, right? So this is about the phase shift keying, quadratic phase shift keying. So we have seen in this lecture that how the digital data is converted into the analog signal. In that we have seen why we are using the digital data, why we are converting the digital data into the analog signal. After that, we have seen its subtype, ASK, FSK and PSK, with its advantages, disadvantages, and how the signal are modulated with its how the signals are modulated by changing its characteristics, right? So this is all about today's video. Thank you for the watching.